Hey guys, welcome back to part 2 of Huffman encoding. So from the previous video we came to learn that we are working with 14 characters and we only need 4 bits to represent all of them uniquely. So now let's see how Huffman encoding works. So in Huffman encoding you have to write down all the numbers each character appears, so 4, 1, 1 and so on. And we have to write them in an ascending order, so all the small ones first and then the big and the last and the biggest one at the end. So let's write it down. So we have written down all the characters in ascending order based on how many times they appear. Now we have to merge them together. So this is where the concept of greedy comes in. We look into the small ones first and then try to sum them up and do the process again and again. So these are 1, 1, 1, 1, 1, this is 2 and 2, this is 4. So we'd be working with the small ones first, so we'd be making a tree structure here, and summing up 1 and 1 would be 2. Then we have these two, so always the small ones first, so these two would be 2 again, and these two would also generate 2. Now what would be the smallest here? So we have 5 2s and a 1 and a 4, so 2s are the smallest here, so we can work with any one of them. So this 2 and 2 sum to be 4, and this 2 sum to be 4 again. The smallest is 2 and we have to work with 4, so we can work with this 4 or this 4. So as this one we haven't worked with yet, so let's use that. So 2 and 4, that would be 6. Now as I said before, we have to work with the smallest one, so let's work with, the smallest one here is this 4 and this 4, so we try to sum this up. So 2 4s would be 8, and finally we have 8 and 6, so we try to merge them together, and this would be 8 and 6 is 14, so this would be 14. So all of these sum up to be in the end 14, which is the number of characters that we had. Now we have to put 0 or 1 in each of the edges. So always remember, in Huffman the values on your left would be 0 and the values on your right, the edges on your right would be 1. So this would be 0 1 0 1, this would be 0 again, 0 1 1 0 1. So this is 0, so this would be 1. So this is 0, this is 1, 0 and 1. So this is 0, this is 1. So you have labeled each edge with a particular binary number, so either is 0 or 1. Now let's try to do the encoding. So how do we do that? We have to write all the characters down. So we had L, E, so these are all the characters that we had. Now we have to look into the loop to find the particular beat that represents that particular character. So this is the root, right? This is where everything starts from, so we have to start from here and go to that particular character. So for L we have to start from here and go to here, so 1 and another 1, so it would be represented by 1 and 1. So see, we told that we needed 4 bits for each character. However, we are in Huffman encoding, we don't need 4 bits, it can be lesser than that. So L is only 2 bits here, but we would have values that have 4 bits, but that would be the max. Okay, next up is E. So where's E? E is here, so we start from here, 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 here. So E has 0, 0 again, 0 and 0. So it has 4 zeros. So see, E has 4 bits, however L has 2 bits. Okay, then T. So T would also have the same amount of bits, however it would be 0, 0, 0 and 1. How about S? So 0, so 0, 0, 1, 0. So in this process, let's write all of them down. So see here that the max, like the characters that have occurred the most amount of time, have the lowest amount of bits here. So L is only 2 bits and space is only 2 bits. So L occurred 4 times and space occurred 2 times. So they have like the lowest amount. Also A is not 4 bits, it's 3 bits. So they would, the ones that appear the most would have the lowest number of bits. So let's try to see how many bits we have used in total. So 2 and 4, 4. So in total we have 31 bits. So if we use the VLC theme here and use only 4 bits, we would have 56 bits. However, using Huffman encoding, we have only 31 bits to work with. So this is much more compressed than the data that we had in, if we used ASCII, which was 112 bits. So we reduced it from 112 bits to 31 bits, which is really good. I mean, really good. So this is all about Huffman encoding. And if you have any questions or suggestions or anything that you want to say, leave it in the comment below, and in the next part we'll be talking about how to decode Huffman. And like, this is a really easy process. You would be giving all of this, and from this you have to decode it, but we would see it in the next video. Thank you for watching.